So we're starting chapter 11, which is integration, which I think is without doubt, by the end of it, the hardest chapter on the A-level course, including the applied things. I think there's an awful lot of stuff in integration. Now, part of the difficulty is that we're putting together an awful lot of ideas that we've seen in other chapters. So, as I've said so many times on so many chapters, first thing is make sure you know the chapters that lead up to this. So make sure you know how to do all the trigonometry, make sure you know how to do all the differentiation from chapter 9, and all the differentiation and integration from year 12. Until you've got those things really sorted out, this is probably not a chapter to be tackling. Okay, so assuming that we've done that, let's start here. On the differentiation chapter, on chapter 9, what we did was eventually we wrote a big list of all the functions that we knew, and this is basically it, right? All the functions that we're really familiar with, that we tend to play with a lot, are on this list. And we learned to differentiate those, and these are the derivatives of those functions. So you might be thinking, well, what we'll do on the integration chapter then is we'll take all of these things and we'll learn how to integrate them, and we'll have the integrals of all these functions written down in a different list. And that's kind of true. We kind of will. By the end of the chapter, we will be able to integrate all of these things. But that's not really the way that we think. That's not really the way that we work. What we do is we just do this. We say to take these functions, we can integrate all of these things. So when we're doing integration, we're looking for something off this list. Okay, we're looking for a polynomial sort of a term, an exponential, an e to the x kind of a term. 1 over x can turn into natural log of x. Sine integrates to cos, more or less. There's a minus sign we've got to sort out. Cos integrates to sine. Sec squared integrates to tan. Sec tan integrates to sec, and so on. Okay, so to integrate, that's what we do. We look for these things. We think of integration as the opposite of differentiation. Now, when we do that, we get this little list here, which is the same thing, right? So what I'd suggest is that you get something like this and put it onto a revision poster or on a revision card, or if you like, write it like this. So the integral of this equals this. So we have to tweak this around slightly. If we're thinking about integrals, it's nicer to think about it this way. Now, that first one's probably not too much of a problem, right? We've known that one since last year, or since whenever it was you finished the last book. So that's the bit that we're used to. Obviously, if we're integrating, we obviously have to always have to remember to add our constant of integration. There's a little tweak here with the natural log. The domain of the 1 over x function is all numbers apart from 0. The domain of natural log is all positive numbers only. So we've got to deal with that, and you'd think, well, we can't just ignore whether it's positive or negative and just bung a mod sign around it, can we? But yeah, it turns out we can, and we're not going to worry about that. Just sort of take my word for it. If we go and faff around with all sorts of careful things to do with integrating and limits and things, then this turns out to be absolutely fine. If I'm absolutely honest, I don't remember what those things are and how we have to sort of formally check that mathematically. It doesn't matter. We just stick the mod sign in there, and then everything's going to be fine. Obviously, integrating cos to sine, integrating sine to minus cos, it's a little bit easier to write it with the minus sign on this side if we're thinking about an integral, but that's basically, that list there is just the same as this list here. If we differentiate these things, we get these things. So therefore, if we integrate these things, we get these things. Watch out for the odd minus sign, and bung some mod signs around the natural log. Okay? Now, that's it for exercise 11a, but just because it's sort of simple doesn't necessarily mean it's easy, right? So let's just have a look at a couple of examples. The first one, I think, probably is easy if we have our list sitting next to us. If we're integrating this, then that is, integrate cos integrates to sine. So 2 cos, so sine x. 3 over x, 1 over x integrates to natural log, so this is 3 lots of natural log, mod of x. X with a square root sign is x to the power of a half, so we integrate to a power of 1.5 and divide by the new power, so 2/3, and the minus sign stays in front, and then we add a constant. So we can integrate each bit separately. Last year integrating was just like this one, increase the power by 1 and divide by the new power. Now we have to look out for 1 over x's, cos of x's, and other things. But if they're on this list, it's not a problem. The second example is a little bit trickier, and this is really why I'm bothering to do this example at all at this stage, I think. And and that is this. 2e to the x, yeah. So 2e to the x integrates to 2e to the x, and leave the minus sign in front, not a problem there. But here, hang on a minute, cos over sine squared, well, that's not on our list. And I don't know a rule for integrating quotients of things, and I don't know a rule for integrating sine squared. Come to that, we know a rule for integrating sine. So what we're going to do, well, we're going to have to rewrite cos over sine squared. But how are we going to rewrite it? Well, we need to rewrite it so it looks like one of these things that we can integrate. So which one are we going to go for? Well, at this point, you need to just be getting good at using your trig identities, right? So it turns out that if we write it as cos over sine, then that's a cot, and 1 over sine gives us our cosec. So instead of that, we can write it like this, and cosec cot is one of the things we can integrate. It integrates to minus cosec. And once we've done all that, we must remember our constant of integration. The other one in the book, which is probably worth looking at as well, this is a definite integral. Now I'm going to ignore the definite integral bit because that's something from first year integration. If you're not happy with that, go back and look at the first year integration chapter. There are videos on this channel in the year 1 pure playlist. But just to point out this one here, we start off, we think, well, that doesn't look like something that we can integrate. It doesn't look like anything on our list. But if we write it like this, then we realise that it's actually the integral of 2 plus 1 over x. So it integrates to 2x plus natural log mod of x. And then because it's got limits, it's a definite integral, we'll put it in a set of brackets and find the upper limit and the lower limit, and so on. I think the rest of it is perfectly followable from the example on page 295. So that leaves us at the end of section 11.1. Good luck with that.